The high acquisition and maintenance cost of the lab equipment has always been one of the biggest challenges for engineers programs at universities. However, nowadays there is a constant need for industry-focused qualifications for the new entrants to the job market. That's why, more than ever, students need to learn and work under this practical approach, a practical orientation towards the industry needs. Unfortunately, due to high costs, many universities cannot afford an appropriate fully equipped laboratory to develop the required practical skills on the students. For this reason, the possibility for students to have a variety of lab equipment to increment and reaffirm their knowledge and practical skills is very limited. A creative solution is possible throughout a university-industry partnership. Tecnológico de Monterrey, Siemens Mexico, and the Siemens Cooperate with Education program have built a partnership, working together to bring innovation and technology to engineering education. We provide a very outstanding solution to fully equip an engineering laboratory and to reduce the cost without sacrificing the functionality or efficiency of the laboratory. Virtual reality labs. A virtual reality machine is a computational application that models and emulates appearance and behavior of a real machine, manufacturing process, or production system. It is based on a set of 3D solids that mimics as close as possible the visual, audible, and functional aspects of the real machine elements. However, the dynamics and behavior of the virtual reality machine are controlled by external devices, connecting the virtual sensors and actuators to the real inputs and outputs of the real controller. The adoption of virtual reality machines to emulate the real process behavior in a 3D environment represents an opportunity for higher education institutions to equip control, robotic and automation laboratories, contributing to students' formation and solving the need of having costly industrial machinery. A virtual reality lab is formed of 4 or more workstations. Every workstation consists of a real programmable controller, a touch panel, and a PC where virtual reality machines execute. Until now, 3 platforms of virtual reality labs, Basic, Standard, and Advanced, have been developed to support the engineering training in automation, robotics, industrial networks, and HMI interfaces. 1. Basic platform. Compact and low-cost automation equipment and basic virtual reality models for high school or technical levels. 2. Standard platform. Modular industrial automation equipment and standard models for engineering programs. 3. Advanced platform. High-performance automation equipment and advanced virtual reality models for graduate engineering programs. An advanced platform of a virtual reality lab for automation and industrial networks has been implemented nationwide in 14 campuses at Tecnológico de Monterrey, namely Monterrey, Laguna, Chihuahua, Sonora, Ciudad Juárez, Morelia, and Aguascalientes were equipped in a first stage. Saltillo, Cuernavaca, San Luis Potosí, Querétaro, León, Toluca, and Tampico were equipped in a second stage. A basic platform of a virtual reality lab for automation and robotics was also implemented at high school level in 5 campuses of Prepatec: Garza La Güera, Garza Sada, Valle Alto, Cumbres, and Santa Catarina. Our immediate objective is to fulfill the equipment with a virtual reality lab of the 19 campuses at Tecnológico de Monterrey that have at least 2 engineering programs. We have by now equipped 14 campuses, and the implementation is already in process in 3 more campuses: Puebla, Guadalajara, and Santa Fe. For the near future, one of the main objectives is to deploy the project in other university systems, private and public systems, not only in Mexico but also in Central and South America. Outside from Tecnológico de Monterrey, the virtual reality lab was already implemented in one of the 29 campuses of University Tech Milenio, a private multi-campus university system. We have also implemented a virtual reality lab for automation and HMI interface in Instituto Tecnológico de Jerez, one of the 320 campuses of the public university system Tecnológico Nacional de México. To reach this objective, we have already built some strategic partnerships with leading companies in Mexico: Sensotec, based in Ciudad Juárez, Chihuahua; Cygnus, based in Monterrey, Nuevo León; Ingeniería Mecatrónica, based in Aguascalientes. Virtual reality labs, equipped with industrial controllers and virtual reality machines, opens the opportunity to solve the problem that many universities' laboratory equipment face. The virtual reality labs allow to reduce the high acquisition and maintenance costs, to give greater flexibility and efficiency to the training process, to have different and complex scenarios for training.
Mi primera experiencia con la máquina virtual fue muy entretenida. La verdad es que era la primera vez que utilizaba la máquina y me permitía ver lo que yo había programado, aplicado. Veías ahí si había una falla, se veía que en un modo real, a escala por ejemplo, se hubiera destruido, se hubiera echado a perder. La máquina virtual te ayuda a prever ese error, corregirlo y volverlo a correr, a ejecutar y tener la satisfacción que lo que hiciste realmente sí funcionó, y ya cuando lo vas a implementar en el modelo real.
Primeramente, procesos reales son menos, máquinas virtuales podemos tener más, por lo que es más personal el aprendizaje. Cada quien está en su máquina virtual, cada quien va haciendo lo que el profesor dice y pues se aprende mejor porque cada quien lo va haciendo. Otra cosa es que nos permite cometer errores. Vaya, en la máquina virtual un error no cuesta nada. En un proceso real puede ocasionar una colisión o algo así que pues va a costar dinero. Después de programar, pues se puede ver en el modelo tridimensional lo que ya había programado. Bastante divertido porque pues se ven las cajitas moviéndose. Si cometes algún error, pues ahí lo ves que se va el pistón o cosas así. Y pues te permite corregirlo y pues me gustó mucho.
Una de las grandes ventajas que yo le veo como usuario primerizo es que puedo, digámoslo así, jugar con la plataforma sin miedo a romper algo. Y eso es bastante una de las grandes ventajas, ya que me permite manipular y jugar con cada uno de los parámetros o cada una de las herramientas sin preocuparme enteramente por el costo o las consecuencias que pudiera haber en un entorno real.
La ventaja de usar las plataformas virtuales es que yo, si me equivoco en mi programa, no pasa nada porque nada más le doy reset y otra vez puedo seguir aprendiendo de mis errores, ¿no? La diferencia que veía cuando usaba un equipo real con el equipo virtual es que cuando queríamos todos usar el equipo teníamos que amontonarnos, ¿no? Y teníamos que estarnos turnando para usar el equipo. Y aquí no, aquí en cada mes estamos utilizando nosotros el equipo y estamos probando los procesos. Yo recomendaría usar las máquinas virtuales porque realmente siento que aprendo.